Hey, what's up, guys? It's me, Mr. Ipock here. Sorry about that. Looking at 8.2, the homework that I gave you tonight to the algebra classes. This is what I gave you. I told you I'd make a YouTube video on it for your help, just in case you got confused. So let's just start off with, we'll jump right into this. If you need to use a digital sheet of paper for this, as far as my space, I'm completely fine with this. You might not have to on the front side, but you may have to on the back side. So let's just jump right into this. Number 4, n to the 4th over 3n. Remember, there is a coefficient of 1 right there. So we ask ourselves, can 1 over 3 be simplified? It can't. It's just simply 1/3. So that takes care of the 1 and the 3. N to the 4th over n is just simply n to the 4 minus 1. Because there's a 1 right here as an exponent. And when you have like bases with exponent and you're dividing, you just subtract them. 4 minus 1 is n cubed. So we say times, because notice the 1 and the n to the 4th were being multiplied, and the 3 times and the 3 and the n were being multiplied because they're right next to each other. So whenever we have this simplified and then this simplified, we just multiply them together to get in simplest form. So we say n cubed, but our thing is we can't multiply this expression times a fraction, so we write this as a fraction by putting it over 1. My final answer, n cubed over 3. Pretty simple problem there. Let's go down to number 9. Looking at number 9, 4m squared n 4th p cubed over 4m to the 4th n squared p cubed. So looking at 4 and 4, okay, when you're looking at these, when you look at this problem, automatically anytime you have something in the numerator and in the denominator, you can simply cancel it. So 4 over 4 cancels because it's the same thing in the numerator and the denominator. All right. Now let's go again. Think about these as just individual problems, and you just have to simplify each one. M squared over m to the 4th becomes m2 minus 4. Well, 2 minus 4 is m to the negative 2 power. How in the world am I going to get that negative off of there? I just kick it off, and whatever I have left, I put it under 1. So 1 over m squared. So that would be 1 over m squared is m squared over m to the 4th simplified. So I'm done with my m's. Now go to the n's. N to the 4th over n squared would simply just be n squared. You say, how do you get n squared? 4 minus 2 is 2. When you have like bases and you're dividing, subtract exponents. 4 minus 2 is 2. But we're going to put it as a fraction, so we put it over 1. So times. So that takes care of the n's. Now looking at the p's, p cubed over p cubed. Same thing in the numerator and the denominator, so it cancels. So I just need to multiply numerators and denominators. So I have 1 times n squared is n squared, and m squared times 1 is m squared. So you have n squared over m squared is your final answer. Okay. Hey, and I'm kind of rushing through this pretty quick, just to simplify. I'm just trying to get it done. But again, you have the ability to rewind. So if you need to rewind, feel free to rewind. Do whatever. Okay. Going to the back side. Looking at number 13. Let's just start with number 13. Number 13 presents a power of a product in the numerator. Okay. So if you remember how to solve, think about this. If I covered this up and I said, hey, simplify this, you would do that by raising each factor to the power. Each factor 2x to the 4th and y cubed to the power of 3. So we're going to raise the 2 to 2 cubed, x to the 4th to the cube, y cubed to the cubed. So now this looks like this. 2 cubed times x to the 4th cubed times y cubed cubed. And then whatever we have left, times 2z cubed, and all that's going to be over our denominator, which stays the same, zy cubed. So the 2, this is a power of a product. It came out to be 2 squared times x to the 4th cubed. Or I'm sorry, I said 2 squared. I actually meant 2 cubed. My apologies. 2 cubed times x to the 4th cubed times y cubed cubed, and then times 2z cubed, which is what we brought down, and the denominator stays the same. 2 cubed is 8, and then we have x to the 4th. This is a power of a power, so you just multiply the exponents. So we have x to the 12th. Y cubed cubed would be y to the 9th, because you just multiply those two numbers, and then we say times 2z to the 3rd power, and that's all over our denominator of zy cubed. Now, before I go any further, I have some coefficients here that I can multiply since they're like terms. So 8 times 2 is what I can say, and I get 16. And then I'm just going to write whatever I have left in the numerator. X to the 12th, y to the ninth, z to the third, and that's all over zy cubed. Okay? So now that I have that, I know there's a 1 down there in the denominator, so 16 over 1 is just simply 16. When I'm looking at the x's, there is no x in the denominator, so I'm going to write 16 over 1 because I'm going to write it as a fraction. I have no x in the denominator, so I can just bring that down and say x to the 12, but I'm going to put it over 1 as a fraction. That takes care of the 16 and the 1 and the x. Now go to the y's, y to the ninth over y cubed. Like bases, dividing, subtract exponents. That'd be y to the 6th power over 1. And then we have, that takes care of the y's. Now the z's, z cubed over z to the first. Like bases, dividing, subtract. 3 minus 1 is 2. So times z to the second over 1. Now multiply numerators and denominators. I would have 16 x to the 12th, y to the 6th, z to the second. And that would be my final answer. I don't have to put that over 1 because basically the denominator is all 1, and anything divided by 1 is itself. All right. Let's take a look at this number 16. It actually looks pretty difficult just by looking at these exponents. I'm going to tell we're going to have some pretty large numbers here. So before we even mess with the larger outside, we're going to have to mess with the inside. Okay, so this inside, this is a power of a product. So again, if we covered up all this right here, we ask ourselves, how do we simplify that for the numerator? So we're going to raise each factor in here to the power. So the 4 goes to the 2, the 4 goes to the a cubed, the 4 goes to the b to the 4th. Again, I know I'm talking pretty fast, but hey, hit pause at any time, try to go back. So I have the quantity of 2 to the 4th power times a cubed to the 4th power times b 4 to the 4th power. And that's all over whatever's in the denominator. The denominator's not changing yet, so we say 2a cubed b cubed times 2b to the 4th c squared, and all of that's going to be to the 4th power. Now before I deal with this exponent out here to the outside, I'm going to simplify this. So 2 to the 4th power is 16, and then this is a power of a power. A 3 times 4 is a to the 12th power, and then b, power of power, b to the 16th, and that's all going to be over 2a cubed b to the 3rd times 2 b to the 4th c to the 2nd, and all of that is to the 4th power. So notice what I've done. This is basically, this problem is what this is with the numerator simplified. So with the numerator simplified, that's what this is. So pay attention, like the denominator hasn't changed at all. This exponent hasn't changed at all. The only thing that's changed is the numerator, and that's because we simplify this power of a product. Now, this is where it gets really nasty. Now you have to raise each factor, raise every single factor that you have to the 4th power. So this could get pretty nasty real quick. So we're going to raise the 4 to the 16th, which is going to be a very massive number. 4 to the a to the 12th, 4 to the b to the 16th, 4 to the 2, 4 to the a cubed, 4 to the b cubed, 4 to the 2, 4 to the b to the 4th, 4 to the c squared. And if you just want to punch your computer screen right now, I totally understand. Right? So, all right, that was me punching mine because this is insane. This is insane, but hey, look, you're about to get this. All right, so now we rewrite that out. So I'm gonna come up here and kind of rewrite that. So it's going to be 16 to the 4th power times a to the 12th to the 4th power times b to the 16th to the 4th power, and that's all over 2 to the 4th power. Again, putting the 4 on, now we're starting the denominator, putting the 4 on everything. 2 to the 4th power times a cubed to the 4th power times b cubed to the 4th power times 2 to the 4th power times b to the 4th to the 4th power times c squared to the 4th power. Okay? And again, that is pretty rough, and you're probably going to have to use a calculator, or if you want to take the time to say 16 times 16 times 16 times 16, you can. I'm just going to do that simple calculation in my head. So that would be 65,536 is what 16 to the 4th power is. And then I say that's times 12 to the 4th power, would simply be you multiply these two, so that's a to the 48th power. And then, again, here we have times b. You say 16 times 4, and that's going to give us 64. And all that is over 2 to the 4th power, which is 16. A cubed to the 4th power is a to the 12th. B to the 3 times 4, that again, you're just multiplying those because they're power over power, b to the 12th power. And then you have another 2 to the 4th, which would be 16. B to the 4th is b to the 4th is b to the 16th. And c to the squared to the 4th is c to the 8th power. Again, I understand that this is a little bit insane, but again, just take it easy. Rewind if you have to, and hopefully I'm talking slow enough that you're kind of seeing this a little bit better. Okay? Alright, so when I'm looking at this, first thing I'm going to do, I'm going to multiply these two coefficients right here, and that's going to kind of take care of these, this number right here. So I'm going to rewrite my next line, 65,536, a to the 48th, b to the 64th, and all that's over. 16 times 16, you all should know that. That's 256. And then that's going to be a to the 12th, b to the 12th, b to the 16th, c to the 8th. Okay. So then from there, now we can start to simplify this. Well, hold on. I have some like terms here, so I need to add those together. So if you're looking at the b to the 12th and b to the 16th, you need to simply rewrite this as 65,536, a to the 48th, b to the 64th, and all that's over 256, a to the 12th. But now let's combine these two b's right here. So when I have like bases and I'm multiplying, I actually add exponents. So it's going to be b to the 28th, c to the 8th. So then from there, now I'm ready to simplify. So 65,536 would be simplified to, if you say 65,536 divided by 256, you're going to get 256. So 256 over 1. So that takes care of those two. And then the a to the 48th over a to the 12th, you subtract exponents. So that's simply going to be a to the 36 over 1. That takes care of the a's. Go to the b's. You have 64 minus 28. 64 minus 28 would be b to the 36th power. And then that's going to be over 1. And then notice we have no c in the numerator, so we're going to put, so times, keep c to the 8th in the denominator and put it under 1. My final answer, 256, a to the 36, b to the 36, all over c to the 8th. And that's that problem simplified. Okay. And just looking at my time here, I'm at 13 minutes, so hopefully that can kind of help you. I'm going to go ahead and log off for the night. Again, guys, all these problems are just alike. You just got to see the pattern of which it flows. Again, it's easy. You guys got this. The best of luck to you. Hey, and don't forget to wear blue tomorrow, okay? Wear blue tomorrow, and let's blow the roof off of the gym, okay? Hey, it's been fun. Thanks, and have a good night.